Everybody, in this video, I'm going to go through our lesson on trigonometric ratios and angles. And the first thing I want to do is have us kind of talk about a right triangle, those trig ratios, and how we use the trig ratios to find angles. So here's our right triangle. This can be A, B, and C. Now I'm going to let this angle A up here be theta. Within this triangle, side AB, the long diagonal side is the hypotenuse, or HYP. The side that is opposite that angle, theta, CB here, is the opposite side. And then the side that is right next to that angle theta is the adjacent side. And we have the three trig ratios we've discussed before. We use that acronym SOHCAHTOA to help us remember them. So the sine of that angle theta is equal to the opposite O, or opposite over the hypotenuse, or H. Cosine, the cosine of that angle theta is the ratio of the adjacent to the hypotenuse, or the adjacent over the hypotenuse is equal to the cosine of that angle. And lastly, the tangent of that angle theta does not involve the hypotenuse. That is simply the opposite over the adjacent. So how do we find this angle theta? We use inverse trig ratios. Inverse trigonometric ratios to calculate the angle measure based on the ratio of the given sides. So we have three trig ratios and therefore three inverse trig ratios. The first one I'm going to talk about is the inverse sine. So all of these, a lot of times the notation we see is the sine to the negative first power, or cosine to the negative first power. So I would say the sine to the negative first power of the ratio, that opposite over hypotenuse, the inverse sine of the opposite over the hypotenuse, that will tell me the measure of my angle. This is really the opposite of our sine ratio. Instead of having the angle in the parentheses, we have the ratio opposite over hypotenuse, and that will tell us the angle. And again, a common notation you might see is this sine to the negative first power, or you could see arc sine. So the arc sine is equal to the opposite over the hypotenuse. That notation will work as well. Both of these equal theta. All right, next we have the inverse cosine. Or COS to the negative first power, cosine to the negative first power. And this, we would evaluate the cosine to the negative first power of that adjacent over the hypotenuse. And that would tell us then the measure of the angle, theta. The other notation here we could use is arc cosine, arc cos. and that is the adjacent over the hypotenuse. So the arc cosine of the adjacent side over the hypotenuse, that will tell us that angle measure theta. So either of those notations will work as well. And then lastly, we have the inverse tangent. Or tangent to the negative first power. And again, it's the ratio of the sides that goes in the parentheses. So here, tangent to the negative first power of the opposite side over the adjacent side. As you might be able to piece together, another notation we might see is arctangent of that opposite over the adjacent side. Gives us that angle measure of theta. I didn't write that up here. That this tells us the angle measure. And either the tangent to the negative first power or arctan work. So let's look at some examples. This does have lesson images. If you can't print them out, these ones are easy to draw. Just rough sketch in your notes of. So given triangle DEF is a right triangle, find the measure of angle E rounded to the nearest tenth. So this image here is DEF. Here we go. Let's try. There we go. The reason why it's written out that DEF is a right triangle is because we don't actually see which angle is the right angle. But by looking at this, I hope we would agree that the right angle is going to be the one opposite the longest side, which here looks like it is EF. So our right angle is this angle D. Now we want to know the measure of angle E. So I'm going to let that measure of angle E be theta that we're interested in. Here is my theta. And we already know that 19 is the hypotenuse. So the other side that we are given is this side that is 7. And the side that's 7, that is directly opposite that angle theta. So this is the opposite. And we also have the hypotenuse. So remembering katoa, we have the opposite and the hypotenuse, which means I am going to use sine. And if I recall, do this in gray, the sine of any angle is equal to the opposite over the hypotenuse, which means I need to use the inverse sine. The inverse sine of that opposite side over the hypotenuse will give us the measure of the angle that we need, that theta. So I'm going to have sine of this opposite over hypotenuse. Now our opposite side is 7 and the hypotenuse is 19. And I totally forgot to write that inverse sine, silly goose. This is sine to the negative first power. And let me show y'all how you need to type this into Desmos. There are a couple different ways you can do it. You can simply type sine and then negative first power and then parentheses, but I think that's a lot of work. So I'm going to go into the keypad. And within the keypad, if you go to functions, you will have all of these trig functions to begin with and the inverses. So I'm going to use sine to the negative first power. And then within the parentheses, I will have a fraction. So I just use the slash. And our opposite, since this is sine, our opposite was 7 over the hypotenuse, which was 19. And I need to check that this is degrees. I'm guessing that it's not. So I'm going to go over in the settings over here, and it's set to radians right now. So I need this to be in degrees. So degrees tells me the inverse sine of 7 over 19 is 21.6182. We are asked to round to the nearest hundredth. So looking at what comes after the 1, right? 61 would be in the hundredths. The 8 after in the thousands place does cause us to round up to 21.62. So theta is, it was 21.6182, blah, blah, blah. So this tells me then that the measure of angle E, which was that theta, is approximately 21.62 degrees. All right, number 2. Find the measure of angle S to the nearest degree. And this time our triangle is triangle SUN, triangle sun. Oops. And we want to find the measure of angle S to the nearest degree. So I am going to let the measure of angle S be our theta, the angle we want to find. So that is this angle here. So what sides do we know? Well, it looks like we have the hypotenuse, the side across from the right angle. That is 13.6. And then we also have the side, the other side that touches or forms angle S. It's not the hypotenuse though, so this is just the adjacent. Now, I hope you might be able to predict which trig ratio we're going to be using here. So, TOA, but I have the adjacent and the hypotenuse, or the hypotenuse and the adjacent, so that leads me to cosine. So I'm going to use the fact that cosine of any angle theta is equal to the adjacent over the hypotenuse, which means then the opposite of this, the inverse cosine, cosine to the negative first power of that ratio, adjacent over hypotenuse, equals the angle theta. Literally just flipped. What was in the parentheses in the first ratio is now outside, and what was outside in the first ratio is now inside the parentheses. All right, so let's fill in all of the pieces. We're going to find theta here using that inverse cosine. So cosine to the negative first power of that adjacent. The adjacent side was the 12.3 over the hypotenuse, which was 13.6. And then I need to navigate over to Desmos. You also can type arc cosine, oops, and that will work too. So I'm gonna do it that way. The arc cosine of this ratio, and within the ratio we need, or within the parentheses, we need that fraction to represent the ratio. Now it's cosine, so adjacent was 12.3 over the hypotenuse was 13.6, and it should still be set to degrees. Okay, perfect. Now we're asked to round to the nearest degree, which actually means I don't want anything past the decimal. So I just want this to be .00. So looking after what comes after the decimal, this 2 is not large enough for us to round the 25 up. So I'm going to leave it at just 25 degrees. So writing this in a little bit here. This was 25.2558 ... So I could say then that the measure of angle S is approximately, rounding to the nearest whole degree, 25 degrees. We're gonna do one more. Number 3, a straight water slide ends at a pool which is 80 feet from the base of the 37-foot tall slide. What is the angle of elevation from the bottom of the slide up to the top? And we are going to round to the nearest 10th, oops, of a degree. So we have a straight water slide that is ending at a pool. So let's draw the pool first. Here's my little pool. Let me even make it a pool. There's some people even swimming in it. Look at that. Wow. Okay. But then we have this straight water slide. I'll do that in red that ends at the pool. We don't really know how long the slide is, but it is straight. And it is 80 feet from the base of the pool or from the base of the slide is where it stops. So from the bottom of the slide to the base, this is 80 feet. And then the slide itself is 37 feet tall. So there's probably like some stairs here going up. So straight water slide ends at a pool, which is 80 feet from the base of the 37-foot tall slide. We want to find the angle of elevation, meaning it's going up from the bottom of the slide up to the top. So the bottom of our slide down here, up to the top. The angle of elevation going from the bottom to the top would be this inside angle here within the right triangle. So note that this would be a right angle simply because this is going to be a perpendicular height. Now, if our angle that I just marked with the theta down here is at the bottom, and we know this 37 feet, which is directly opposite it, and we also know this 80 feet, which is directly adjacent to it, which trig ratio would be most appropriate? Not sine, because I don't have the hypotenuse, not cosine, because I don't have the hypotenuse. This would be a great time to use tangent. And the tangent of any angle is equal to the opposite over the adjacent. And we know the opposite over the adjacent. I'm going to use the inverse tangent. I'm going to say tangent to the negative first power, the inverse tangent of that opposite over the adjacent. That will give us the theta, or the measurement of our angle. So let's see. Tangent, or inverse tangent, sorry, we're finding the angle. The inverse tangent of the opposite side, which is 37 feet, over the adjacent side, which is 80 feet. That will tell us the measurement of our angle. So let's pop that into Desmos. So I'm going to use the functions. So in the keypad, go to functions, tangent to the negative first power, and then I need a fraction. And this is opposite over adjacent 37 over 80. And it should still be in degrees. I always double check. Now we are rounding to the nearest 10th is what the problem told us, so which means I don't really want anything past this 8 here. The 2 next door is not large enough for us to round up, so I'm just going to leave this at 24.8. So tangent to the negative first power, which reads as inverse tangent of that 37 over 80, gave us 24.82 blah, blah, blah. as our theta. So that angle is approximately 24.8 degrees. Ooh, I don't know why I even decided to box it. Please let me know what questions you have. These can take some practice. I'm absolutely here to help, and I look forward to seeing you soon.